Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about one more example of the probability density function PTSP problem. And this is the previous examination question. The given example is check if 6x into 1 minus x for x taking all values in the range 0 to 1 including both 0 and 1 is a probability density function. So given that the probability density function small f of x is equal 6x into 1 minus x for x is equal to 0 to 1 and f of x is equal to 0 otherwise. So check it, the given density function is valid density function or not. How to check the given density function is valid function or not using properties of the probability density function. So we know that one of the property of the probability density function is the area under the probability density function curve is always equal to 1. That is integral minus infinity to infinity fx of x dx is equal to 1. So now here from the given data, the probability density function is 6x into 1 minus x for x is equal to 0 to 1. Okay. So this integral term. So now consider integral minus infinity to infinity fx of x dx. So that value, that integral value is equal to 1. Hence, the given density function is a valid density function. Otherwise, not a valid density function. So now calculate integral minus infinity to infinity fx of x dx value. So now here fx of x value is 6 into multiplying the x into within the bracket term 6 into x minus x square dx. 6 is constant that is written before integration. Integral x is x square by 2. Integral x square is x cube by 3 over 0 to 1. Now applying upper value of x and lower value of x, and upper value of x is 1. So 6 into 1 square is 1, 1 by 2 minus 1 cube is 1, 1 by 3 minus lower value of x is 0. 0 square is 0, 0 by 2 is 0 minus 0 cube is 0, 0 by 3 is 0. And the second term, when you substituting lower value of x, the second term is 0. And here take the LCM. 6 is the LCM. 3 minus 2 by 6. 2 into 3, 6. So therefore, the density integral minus infinity to infinity fx of x dx is equal to 1. Now here the condition is satisfied. That is area under the probability density function value is equal to 1. Hence, the given probability density function is a valid density function.